Introduction to actuators. So the machines, they don't just think, they act. Now here the part that performs the physical action, it is called as an actuator. So actuator, it is a device which will receive a control signal and then it will convert it into a physical movement and changes it to the real world environment. So here the control signal, it may be in the form of electrical or the electronic signal which will be given as input to the actuator, and the output will be a physical movement that will be any mechanical action. So actuator may or may not require any power source. If it requires, then you can give as another input for the power source here. Then this physical movement, it will have some effect in the environment, that it will change the real world environment. Now examples for actuators are electric motors, which will produce a rotary motion, solenoid and the hydraulic cylinders which will produce a linear motion, or the speakers which will produce the sound. You may have some other examples also, such as robotic arm moving, door opening and the wall turning, and many more such examples. So here the flow is the control signal will be given as input to the actuator. It will produce some physical movement which is nothing but the output, which will have some changes in the environment, that is, they will have some real world effect. Now here we'll see how an actuator works. The first step is the control system will use the signal, that is, you may have a microcontroller, PLC or the computer which will be acting as a control system, which will send a command signal to the actuator, and the signal may be a digital signal or an analog signal. So here the processor will send the command. For example, it will tell rotate the motor. Okay, then next step is next here the processor will control the system and it will produce some digital signal or the analog signal which will be given as input to the actuator. So the actuator will receive the signal, and that is the electrical signals, and it will convert it into physical output. So the actuator will convert the electrical signal into motion, force or the rotation. Fine. Then here you can see this is the actuator input, to this is the electrical input, and output will be the physical output. Now there will be some changes, environmental changes. For example, the physical output which has been produced by the actuator, it will change the real world environment and it will perform the required action. For example, it will the robot will lift the box, the fan will start rotating, or the car brakes will be applied here. Okay. Next, you have one simple actuation mechanism where this figure it will shows that how machines move from thinking to doing. Now first block is the monitoring, which may be a laptop or a remote user. Meaning to say here is the human or the system will give the command. For example, you'll be having a factory supervisor which will who will press some button called as move box A. Okay, so here this monitoring, it will act it is the brain which gives the instruction. Second block is the processor, which may be a sensor node or the processor. Second block is the processing, which may be a sensor node or a processor where it interprets the command and it will convert the human instruction and generate the machine language signals. For example, microcontroller calculates the motor rotation angle. So here the processor, it will decide how the work should be done. Then third is the actuation, where you have a motor driven mechanism. This actuator, it performs the physical action, and here the motor driven robotic arm will move, that is starts moving. So the actuator, it is like the muscle of the system. Okay. Then fourth block is the environment, where you are taking one example for factory automation, and here the box will be moved in the factory. So here the environment shows that the final result of the machine action. Okay, it will show the final result of the machine action. One example for the robotic arm we have taken here to show how the actuator works. So first the remote user will send the command. Okay, suppose the operator will press pick and place the box. He is saying to pick the box and then place the box. So the input is the human command, this may be given via through the remote HMI or the computer. Now the processor will give the instruction to convert this human command and generate sequential motor instructions. Okay, like move the arm, rotate, lift, place. You will be having some sequential instructions for this. So the processor, which is acting as a brain, will process the command and it will create the step-by-step instructions. Next, the control signal will be sent to the actuator. That is, the signals will be sent to the motors or the servo drives. We are having the digital signal and the analog signal. These may be sent to the actuator interface or the driver, or to the servo driver drive or the motor. Okay, this will be acting as a controller. Now last step is the actuator will move the robotic arm. Okay, this is the final action. That is what the remote user has given the command, pick and place the box. So here the boxes will be picked and it will be placed. That is, the boxes are moved successfully. So the output is the physical movement is happening here, and this is where the actuator is performing the physical work. Okay, so this is a flow. That is, user is giving the command, processor is generating the instructions, then the control signal will be given to the actuator. The actuator will move the arms and some physical action will be taken here. Okay, that is, the box will be moved. So the actuator, it is like it acts as the muscle of the machine. Now we are having what? We are having sensors, processors and the actuators. So the sensors will observe, processors will decide and actuators will act. So sensor observe, that is, they will collect the data from the environment. The processor will decide, that is, it will process the data and make decisions. Now it will produce the control signals, which may be digital form or analog, which will be given as input to the actuator, which is acting as a machine of muscle of the machine. So it will convert the signal into motion, force or rotation. Then the signal will become motion through the actuators. That is, it will take some physical action. So here the output is what? Output is the physical action. That is, the robot may move the arm, robot arm moves, and the fan may rotate, car may apply, the brakes may be applied in the car. Okay, so here these are some types of the actuators. Now actuator, it is like the muscle of the machine. Without the actuators, machines can think, but they cannot work. Okay, so next, the signals become motion through the actuators, that it will take some physical action. Then processor is the brain, whereas the actuator is the hand. And the IoT, Internet of Things, it is incomplete without action. And action from where it comes? It comes from the actuators. So from the command to the movement, actuators will make it real. Even though we are giving the command, the machine will think, but to take any action, the actuators are required. To make it real, we need the actuators. Here you have one mini demo idea which you can perform in your class. Suppose you are there are 3 students. Student 1 is acting as a remote user, student 2 is acting as a processor, and 3 is acting as an actuator. So the student 1 who is acting as a remote user will give a command, move the chair. Okay, this will be given as a signal to the processor. Okay, now the processor will think, it will receive the command, it will process it and it will give the instructions. So here it will say that, okay, I will move the chair. Okay, now this is given as an instruction. This instruction is given to the actuator in the form of signal. So the actuator will move the chair. Okay, that is, it will execute the instruction and it will perform some physical action. Fine. So here the actuator student, that is student 3, is nothing but the actuator. She is physically moving the chair. So in general, remote user will say the command, processor will process and repeat the instructions, actuator will perform the action, and there will be some physical action, that is movement of the chair. So this is about the introduction of the actuators. Thank you.